recording and upload it today night. Okay, so welcome you all to the first session of computer system design. So, um, as like normal other degree courses, for most of the courses, like we have like two quizzes and a hintum as far as uh, the evaluation that yeah the assignments as well as that exam requirement. And um, the plan for today, like we thought of start with some theory because that number system part is not very discussed in very details. uh, Sir has definitely discussed it, but as I seen in the discourse, like few people want it in more detail. So we thought of to have spend few time on that particular like number system sometime. And after that, like if you have some questions, we can will be happy to address those questions, right? So um, I think we can start, right? You want to ask anything before we start? Okay, so maybe we can start. Yeah, Manideepa, you want to start today?
Yeah, sure, sir.
Okay, thanks.
Okay, hello everyone. So today we will be starting with a number system. So let me just share my screen. So is it visible?
Yes, yes.
Okay. Okay. So first of all, we will be discussing four of the major number systems in this
Manideepa, if
course.
possible, you can increase the size a bit.
Okay, sure, sir. Is this
Yeah.
okay?
Okay, yeah. Everybody, it's visible, right?
Yeah,
Yeah.
it's visible, but
Yeah.
it would be better if she goes full screen. There's an option for that. And the extra bars are taking up way too much space.
Is
Yeah,
this
that's
Uh,
okay?
much better. Much better. Thanks.
in this, I think she may only.
Actually, I would need to,
Yeah, she only
write
able
on
to.
the screen. That's why.
Yeah.
Oh, okay. It's fine. Sorry.
So this size is okay, I think.
Yes, yes, yes.
Yeah.
Okay. So here we will be discussing four of the major number systems. Okay, so firstly decimal numbers, then we have binary numbers, and we'll also be discussing octal numbers, that is the base 8 number system. Base 8, and we'll also be discussing hexadecimal. So that is base 16. So in this notation, you can see that if we take the number 5347, this is a decimal number. You can see the base is 10 here. So here 4 is the digit in the ones column, and in tens column we have 7, in hundreds column we have 3, and in thousands column we have 5, which means 5374. So this is a decimal representation of a typical number. Okay, so similarly in binary, what we do is, in binary we only have two digits, like 0 and 1. So here in this number 1101, this one is the ones column. This 0 we'll call it the twos column. And this one we'll call it fours column, and this will be eights column. Now, how are we getting this 1, 2, 4, 8, right? So this ones column basically designates 2 to the power 0, okay, which is 1. And twos column is 2 to the power 1, which is 2. Similarly, this is 2 to the power 3, this is 2 to the power 4. So like that, if we have a larger number, say if we have more ones here or zeros here, we will have 16's column, 32's column, right? Just increase the power of 2. So this is just a normal representation of how decimal numbers are written. So this is the thousands column, 5 is in thousands column, so 5 into 10 to the power 3, plus we'll have 3 which is in hundreds column, so 3 into 10 to the power 2, 7 which is in tens column, so 7 into 10 to the power 1, and 4 which is in ones column, so 4 into 10 to the power 0. Similarly, we can write binary numbers like this one. This is in ones column, right? So we will designate it as 1 into 2 to the power 0, which is basically 1. Now this is in 2's column. We will write it as 0 into 2 to the power 1, which is the 2's column. Similarly, this is 4's column, this is 8's column. So like this, you can write it. So if we want to convert this 1101 into its decimal equivalent, then this is how we will do the conversion. Okay. So I'll take one more example here. Let's say I want to convert 111010. This is in binary. I want to convert it into its decimal equivalent. How will I do that? So firstly, this is my digit in my ones column, right? So I will write it as 0 into 2 to the power 0. Next, I have 1, which is in 2's column. So basically 2 to the power 1. So I will write it as 1 into 2 to the power 1. Similarly, I will go towards the most significant bit. So this is 0 into 2 to the power 2 plus 1 into 2 to the power 3 plus 1 into 2 to the power 4 plus 1 into 2 to the power 5. Right? So here I will get 2 to the power 5 is 32 into 1 is 32 itself plus 2 to the power 4 is 16 plus this is 8. This will give me 0. This will give me 2 and lastly 0. So adding these, I will be getting 48. So I'll be getting 58 by adding this. So basically, this is the binary representation of the decimal number 58. So this is how we convert from binary to decimal. Now we can do the other way around also. So say I have 58 base 10, I want to find its binary equivalent. So how can I do that? So the easiest way is to just keep on dividing your decimal number by 2. Okay. So the first time I divided by 2, I will get 29, right? So do I have any reminders after I perform this division? No, right? So I will write a 0. Again, I will divide it by 2. So here I will get 14. That is the max number of 2's I can fit into 29. So I will still have one reminder. So I will write that here. Now when I divide it again by 2, 2 sevens are 14, so 0 remainder. Again divided by 2, 2 threes are 6, so 1 remainder. Again divided by 2, 2 ones are 2, so 1 remainder. Now when we try to write the decimal equivalent, we will go from bottom to top. Okay, this is how we will see the numbers in this order. So I will have 111010. See, I've gotten back the original binary number. So is binary to decimal and decimal to binary conversion clear for everyone? Yes or no?
Yes. Yeah.
Okay, great. So these are some of the powers of 2. That is, it's good if you can remember it. It's nothing, just let's write it down. I think it's written over here. Yeah. So these are some of the powers of 2. So this will be easy for, if you remember this, it will be easy for you to perform the conversion since you have to multiply with the powers of 2, right? So I think remembering up to 2 to the power 10 is enough. Next, okay, let's take one more example. Binary to decimal conversion. So my number is 10011. This is in base 2 and I want to find its base 10 equivalent. So what I'll do, this one is in 1's column. This one is in 2's column. This one is in 4's column. This is in 8's column. This is in 16's column. So we'll write it like 1 into 2 to the power 4 plus, I'm starting from the MSB, 0 into 2 to the power 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Right? So this will give me 16, this will give me 0, this will also give me 0, this will give me 2, and the last one will give me 1. So this is basically 19 in decimal number system. So the binary representation of 19 is this. Okay. Similarly, you can do one more, convert this to decimal. Okay, that is the same example. Hold on. Okay, so let's convert 47 base 10 to binary. Okay. So we'll do the same division. So 47 is an odd number, so obviously we will get a 1 remainder. Again we get 23, so we'll get a 1 remainder. 11, so 2 5s are 10, 1 remainder. Again 5, here we'll get 1 remainder, and lastly we'll get a 0. So what will be the binary equivalent? Go from bottom to up. So 1 0 1 1 1 1 base 2. So this is the binary equivalent of 47 base 10. Okay. So look, in an n-digit decimal number, how many values can we get? If we know that there are n digits present in a decimal number, how many values? What is the range? So for example, if I have a 3-digit decimal number, then I can get 10 to the power 3, that is 1000 possible values. Now what are those values? Anything ranging from 0 to 999 included, including 0 and 999. Okay. So just to generalize, we can write that if I have an n-digit number, I can have 10 to the power n, that is 0 to 10 to the power n minus 1 possible values. Similarly, for an n-bit binary number, we can have, say I have a 3-digit binary number, say I have 101. Okay, this is a 3-digit binary number. So how many such 3-digit binary numbers are possible? 2 to the power 3, that is 8. So that will range from 0 to 7, right? Okay. Now I will tell you a little bit about octal system before we go to hexadecimal. So in octal system, which is basically octal means base 8. So in base 8 system, what are the digits that we have? It is everything from 0 to 7, including 0 and 7. Okay. We don't have 8. We have 0 to 7. So in octal number system, we can convert between any number system. Okay. We can do binary to octal, decimal to hexadecimal, whatever you want. So there are different processes for that. So I will show you one. Since we are done with decimal and binary, let's take one octal number. Okay. And let's convert it. Let's take one binary number and convert it into its octal equivalent first. So say I have one binary number, this. Okay, I don't know what this is in its decimal equivalent. So let's just take this. So the simplest way of converting this into its base 8 octal denomination is just group the number of digits by threes. Okay, so take 3101 and start from your left hand side. I'm sorry, start from your right hand side. Okay, so I will start grouping this in threes, groups of threes. So 101 is one group, this is one group, and now I only have 2 digits, so I will add a 0 here. It doesn't matter, you can add as many zeros as you need. So now what we'll do is we will individually find out the equivalents of these groups. Okay, so 101 in binary is how much in decimal? It is 5. 011 in binary is the decimal equivalent of 3, and here also 3. So the octal number here is 335. Okay, so you can recheck this. So if I want to convert from this 335 to this binary equivalent, I have to take the help of decimal number system. Okay, so first I will have to convert this into its decimal equivalent, then we will do the binary equivalent. So how do I convert 335 base 8 into its decimal equivalent? So in this case, 5 is the one that is in the ones column. Okay, this 3 is in 8's column, and this 3 is in 64's column. So basically 8 to the power 0, 8 to the power 1, 8 to the power 2. So we will write it down, break it down. 3 into 8 square plus 3 into 8 to the power 1 plus 5 into 8 to the power 0. Okay. So what are we getting? 64 into 3, that is 192, plus 8 3s are 24, plus this is 5. So this is 202, 212, 216, 221. So 221 is the decimal equivalent. Now we have found that 335 in base 8 is equivalent to 221 in base 10. Now we can convert this into its binary equivalent and see if we get back this. Okay. So here I will have 110. So 1 remainder. I'll have 55. So 0 remainder. Next I will have 2. So this is 27. 1 remainder. This is 13. 1 remainder. 6. 1 remainder. This will be 0 remainder. Here I'll have 1. So here I will go from bottom to top. So what will this give me? 1 1 0 1 1 1 0 1. See, 1 1 0 1 1 1 0 1. So I'm getting the exact number back, right? So this is how you can convert from base 8 to binary and from binary to base 8. So I hope this is clear for everybody. If anyone has any questions, you can ask. Okay, so next we have hexadecimal number system. So that is basically base 16 numbers. So we can write down the hexadecimal numbers for the decimal equivalents. Okay. So 0, we will write it as 0 only. In binary, see, for hexadecimal numbers, we need to have at least 4 binary bits, okay, to represent hexadecimal in binary. Similarly, in octal, we need 3 bits for its binary representation, at least for every single digit in octal system. And for every single digit in hexadecimal, that is base 16 system, we need at least 4 bits for its binary representation. So in hexadecimal, this is 0. In binary, we can write 0, 0, 0, 0, right? So this 1, I will in hexadecimal also write 1. Here I will write 0, 0, 0, 1. 2 in hexadecimal will write same 2. Here I will write 0, 0, 1, 0. 3 will be 0, 0, 1, 1. 4 is 0, 1, 0, 0. 5 is 0, 1, 0, 1. 6 is 0, 1, 1, 1. I'm sorry, 0, 1, 1, 0. 7 is 0, 1, 1, 1. 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. Now here's the fun part. So in decimal, we have 10. So to represent this 10 in hexadecimal, we will be using alphabets. Now everything that comes after 10 till 15. So in hexadecimal, we have 0 to 15. Right? These are the digits we can use in hexadecimal number system. So anything after 10, anything after 9 actually. So from 10, we'll be using alphabets only. So 10 I'll represent as A. Right? And in binary, I can write it as 1010. 11, I will write it as B. And here I can write wait, my pen is not working. 1 minute. Yeah, 1011. Right? So C, I will 12, I will write it as C. 1100. 13, I will write it as D. 1101. 14, I will write it as E. That is 1110. And 15, finally, I will write it as F. So that is 1111 in binary. Okay. So this is how you represent the numbers, the decimal numbers in hexadecimal as well as binary. So anything after 10, you represent it with alphabets. Okay. So let's take one more example of converting between binary and hexadecimal. Okay. So I will take one number 1101 0011 and let's take 1110. Okay. So this is my binary number and I want to convert it into base 16. So I will take groupings in 4 this time. 4 bits I will group starting from the least significant bit, that is this one. Okay. So these 4 bits I took, next 4 bits, next 4 bits. Okay. So first we are converting into decimal. We cannot do directly into hexadecimal. We can, but it's a more complicated process, but let us do it through decimal. So when we take groupings of 4, so 1110 is what? Can anyone tell me what is 1110 in decimal? I just showed you the number system chart.
14.
Sorry?
It's 14.
Yeah, right. So it's 14, but we will not be writing 14, right? We can write it as E. Okay. Here,
3.
so this is 3. 3 I can write it as 3, and 1101 is anyone?
It's D.
Yeah, right. It's D. So here's my hexadecimal equivalent D3E. This is in base 16, right? So now if I want to convert this number into binary, then I have to take the decimal number in between before I can get the binary equivalent. So base 16, in base 16, this is the equivalent D3E. So if I want to convert this into binary, okay, then I have to find the decimal equivalent first. Then from that we can find the binary like we did in octal. So you guys can try this example yourself. So that's about it. That's about the conversions, and I think this will be enough for you guys to uh, be able to solve the questions. Now I will just show you one more thing. Say I have a number system. I don't know the numbers. I don't know the base of a number. Okay, so I have been given 34, but I don't know what base it is in. So I can consider it is in base B. Okay. So from this information, what can I say? That what number system can this possibly be in? Any idea? Like at least give me the range of the number systems it can possibly be in. That is the base. See, there are
Should be
not
greater
only,
than
yeah,
5.
exactly. It can be 5 or greater than 5, right? So base can be, so B is greater than equal to 5. Now, how are we concluding that? It's because, see, I can have numbers in any base. Okay. 1, 2, 3, 4, 5, 6, any base. So, like I told you that in octal number system, since I have base 8, so I can have numbers from 0 to 7. So here I can see I already have the digit 4. So it means that I at least have to have a base 5 number system where I will have numbers from 0 to 4. If I have base 4, then what will happen? I cannot have this 4 digit here because I will only have 0 to 3 digits, right? So this is what we can conclude. So I think this much about number system is pretty much enough. So any questions, anyone? Or you have any doubts regarding week 1 lectures, you can ask.
What about other operations in number system? Like if there is a different number system and you have to do subtraction, multiplication and division.
That won't be required. It's not required in that much detail. The amount that is given in your resource is enough.
Actually, in the practice assignment, there was one question at the end, the last
Yeah.
question.
Yes.
It was asking about which number system it is, and it was a division problem.
Okay. So see, one thing I will tell you here. I think the problem was something. Can you give me that value? What the division was? Do you have the question open or do you want me to check?
It's 514 by 20,
514 by 20,
equal to 24.2.
24.2. Okay, right. I will explain this to you. So this is just one problem. For this, you will need to do some extra things here. So I think we are supposed to find the base that this is in, right? The number
Yes,
system.
yes.
So what we will do to solve this is we will consider the base of all of these as B. Okay. So let me take this as base B here also. Okay. So now what I'll do, one thing I will tell you. So anything, if I have a decimal point, okay, so anything that comes after that point, like we were writing, this is in ones column, right? So this will be -1. So this will be anything here. So this 2 I can represent it as 2 into 2 to the power -1 if I'm talking about this binary. Okay. So whatever number system this is, I have to write say here I'm considering it as b, so I will write 2 into b to the power minus 1. If I have a 3 here, I will write it as 3 into b to the power minus 2 if I'm converting, okay, to decimal. If I need to convert this to decimal, I will be converting it like this. So the negative powers will just increase in this direction. All right. So to solve this, I will just write the first step. I think you can do the rest. So this base b. Now I want to convert all of this. See, if I convert this in decimal, and then perform the division, and then I convert this in decimal, then I should have equal results on both sides, right? So I'm taking everything in decimal base. So here we will have 5 into b square plus 1 into b plus 4 into b to the power 0 by, since 0 is not required, so I will write 2 into b. In this side, similarly, I can write 2 into b plus 4 into b to the power 0 plus 2 into b to the power minus 1, which I can write it as 2 by b, right? B to the power minus 1 is nothing, 2 by b. So I think after this, you can solve the question, right? It's just an equation now.
Okay, got it.
Okay, this is how you need to do. Okay. Any other question? All right, so I will stop sharing my screen. So if there are no other questions, I think we can wind up the session here.
Yeah.
Okay.
So
Thank you,
anything,
everyone.
yeah, Pritodeep, Cherian, anything about the course, about the content? Okay. So shall we close then?
Yes, sir.
Okay. Okay, Shubhan, you can stop the recording.